Today we'll be looking at another atomic property and its variation in the periodic table. Ionization energy. Now in our previous class we have already looked at the variation of atomic size. We also looked at how elements are arranged in the periodic table using the electronic configuration. So if it's your first time, do not forget to follow us. And students that are in our summer school tutorial, please do like, share, comment. What's going to share so that your fellow colleagues and mates will benefit and friends. Share it on your wall. Alright. What is ionization energy? Ionization energy, simply put, is the amount of energy required to remove an electron from an atom of an element. The amount of energy required to remove an electron from an atom of an element. Now, if an element X undergoes ionization, you will form X plus 1. When the first electron is removed, it forms the first ionization energy. If this same element undergoes ionization to form, release 2 electrons, it forms the second ionization energy. So depending on how many electrons you will determine the ionization. But majorly we'll stop at the first what? Ionization, the second what? Ionization energy. So majorly you can see that ionization has more to do with what? Metals. Because they are the ones that have the tendency to give out electron. Simple reason being that they are what? Electropositive. They are atomos electron. From what we discussed about the atomic size, we realize that as we move down the group of elements, metals have big size, and the atomos electron is just either 1 or 2. They are not plenty, so it's easier for them to lose it than to what? Gain more to attain the octet structure to become stable. And because of that, metals are said to be what? Electropositive. That is the ability to give out what? Electron. The electro what? Positive. The ability to give out what? Electron. You know, in chemical combination, we say every element goes into reaction because they are trying to attain either the octet or the duplex structure in chemical combination. That's why they go into reaction. So if you are having, let's say, 1 electron in your atomos shell, you'll be needing 7 to attain stability. So it's either you give it out and fall back to your octet configuration, like here, either give this one out and fall back to the duplex structure, or this one you give this one out and fall back to the octet structure to attain the double gas structure and become stable, or you look for 7. The energy you will need to look for this 7 is high. So it is easier for metals to give out either 1, 2, or 3 electrons to become what? Stable, than to look for either 7 or 6 electrons to become what? Stable. That's why we say metals are generally electropositive, while non-metals are what? Negative. Electropositivity is the ability to give out electrons, while electronegativity is the ability to what? Accept electrons. Now back to our discussion. Now, moving across the period, this is our period 1 still here. Moving across the period from left to right, what happens to the ionization energy? Remember we say, as we move from left to right, the atomic size decreases because the effect of the nuclear force becomes more felt on the outermost electron. And so because the nuclear force has more effect on the atom as we move from left to right, the atomic size becomes what? Reduced, because the nuclear force is pulling the electron towards itself. The atomic size, that means this electron is bigger than this. This is bigger than this. This is bigger than this. And this is bigger than that. That is because of the effect of the nuclear force that is increasing as we move from left to right, because of the increase in the number of protons and electrons. So because of that, ionization energy, as we move from left, remember we said ionization energy is the energy needed to remove an electron from what? An atom of an element. So as we move from here to here, as the effect of nuclear force increases, it means that it is holding the electron more tightly as we move from left to right. That implies that you will need more energy to remove the electron. So as we move from left to right, ionization energy will do what? Increase. A more electronegative element, that is element that can accept an electron, will require more ionization energy than a less electropositive element. Simply put, metals require less ionization energy, one non-metal require higher ionization energy. Now, as we move down the group, what happened? As you move down the group, due to the effect of internal screening, the screening of inner orbitals, shielding and screening caused by these inner shells, we have agreed that the effect of the nuclear force being screened cannot be felt completely by the outermost electron. And so we establish that as you move down the group, the what? Atomic radius does what? Increases. And because the outermost electron is not tightly held by the nuclear force, as you move down the group, what we are saying is, as you move from here, because it's only one shell, close to the nucleus force will hold this electron more tightly than this one, that this shell is blocking it from this outermost electron. This shell will screen this one electron from the nucleus. So some of the force that is coming from there will be shielded, and so it will not be held tightly. Also here we have two shells shielding this electron from the nuclear force. So when this first shell shields it, this second one will still shield it. This screening effect will reduce the force coming out, so this electron cannot be held tightly. So as you move down, the effect of the nuclear force decreases. And so because the external electron is not held tightly, the amount of energy needed to lose it will not what? Diminish. So as you move down the group, ionization energy does what? Decreases. So across the period, ionization energy increases, while down the group, ionization energy decreases. So that is the property, that is how ionization energy varies in the periodic table. Please do not forget to share, like, and leave your question in the comment section.